our title is HUB SPROCKET. Okay, HUB SPROCKET is a mechanical component. It's a component part to put at a motorcycle, with model Y15 model from Yamaha. Okay. Okay, let's proceed to our objective. Okay, objective 1. To understand the concept of use of computer in design and manufacturing. Okay, for the second one, to develop 3D modeling skill required for the product. Okay, for the third one, to understand the nature and significance of NC machine tools. Okay, basically, in industry, any manufacturer company will produce their product with different purpose to us people daily life, like a automobile company that produce a motorcycle, and electronic manufacturer that produce electronic device, and a lot of more. Okay, before any component is created, a manufacturing company has to come up with idea along with the concept in product design and develop. The product concept is one of the methods to produce a product that include 3 primary categories with an illustration, physical principle, material, and abstract embodiment. In the illustration category, computer-aided design or any other kinds of software used to translate the idea of the design into something that other people could understand. Okay, for in our project, we apply on it and start our idea and apply to computer-aided design, and using our method to translate an idea to design. Okay, based on some research and knowledge that we have learned during lecture class, computer-aided design involves creating computer models defined by geometrical parameters. It appears as a 3-dimension representation of a part of a system of components, which can be daily after by changing relevant setting. CAD system enable design to view objects under a wide variety of representation and to test this object by simulating real-world conditions. Therefore, computer design manufacturing use geometrical design data to control automate machinery. Okay, CAM systems are executed with computer numerical control (CNC) or direct numerical control (DNC) system, since both of computer-based method for encoding geometrical data. They are commonly referring to as CAD/CAM. For our project, we assign to choose an appropriate product with a degree of complexity in shape, contouring, profiling, bracketing, and machining factors, with the knowledge and idea on the processing method that will be required for the part to be creating in the real manufacturing situation. Meanwhile, the product that we choose has to design using solid modeling, that has to develop or model using solid modeling and apply technique. Plan machining strategies and tool part method by using CATIA software. Okay, let's proceed to organization chart. Okay, let's proceed to organization chart. Okay, my lecturer, as we know, Mr. Zulkarnain bin Marjum and Mr. Nazri. Okay, my captain or my leader is Muhammad Luqman Nur Hakim bin Ahmad Daham, and my group member Al-Silayu and I Abdul Muiz bin Muhammad Shukri and Muhammad Afiq Asna bin Hassan and Muhammad Syahir bin Ishaq.
Moving on to project planning. As we all know, in any project that is going on, they must have a good planning to produce a good part. So in our project, we started with selecting automation part. For example, for our project, we choose HUB SPROCKET. Before that, to start with our product, we have to propose a proposal to our lecturer or supervisor to have an approval. Once we have an approval from the supervisor, then we're moving on to sketching of 2D. In this sketching of 2D, we are required to have the physical product or real product so that we can have the exact dimension of each part, each side of the part. So that we can move to solid modeling. Solid modeling is done by using a CATIA software, and that will be discussed or presented by my friend later on. And moving on, after we're done with solid modeling and we move to preparation of CATIA, then machining process on CATIA, simulation, and finally the report of this project. Sorry. So let's move on to the next. Alright, here you can see that this is our Gantt chart and the progress of our project for the whole 15 week. Sorry, and you can see that we are given 9 tasks to complete within the 15 week. So the red color is indicate the planning to complete the product, and the light pink color is indicate our actual progress to complete the task given. On the number 5 task, we took a bit of time to complete it if compared to the planning, because we have some difficulty to have to get the real dimension of the product, as we don't have the physical task, the physical part with us. So we have to do some research and some advice from our lecturer to do the machining process according to the tools that are available in our lab. So we took a bit of time on this, and we're still catching up on the planning that we have done on other tasks, especially for our preparation of report. We did exactly like the planning, and we completed it on the 14th week, and yeah, that's about it. And moving on to the next slide is prepared by my friend. Thank you.
Thanks to my friend Elsie for the good explanation about project management, which is project planning and Gantt chart. First thing first, my name is Muhammad Luqman Hakim bin Ahmad Daham, and my student matric number is B0918100150. So, today I'm gonna talk and explain about our project detail and my part is to explain about our 3D modeling. So let me start the first slide of the subtopic. As you can see, this isometric view, our group already go through so many steps and process to finish up and build this part using the dimension that we have done before. In this part, 3D modeling, we apply that command that offered by CATIA version 5 software, which is pad command, pocket command, fillet command, and hole command to certain suitable sketch or area that we want. Then we go to our part with stock. We are using the 100 times 100 mm for the height and width of the stock, and will apply 56 mm thickness of the stock. The total height of our part is 47 mm, so we apply 3 mm extra stock at the top for the facing process and 6 mm at the bottom for the clamping purpose. After finish build this part and the stock, we apply the exit system at the edge of the stock for the WPC and need to assembly with the plane system for the next step. Okay, that's all from me, and I will pass to Afiq Asna to continue this presentation. Okay, thank you.
So hi, so I will continue this presentation. So this is the actual product that we want to use, we want to do in the CATIA, in CAD-CAM. So after we find the dimension and also we do some sketch on the AutoCAD, then we do in the design and on the CATIA, and now this part of the machining process. So this is our tools that we use to cut the material. So they have 4 type of tools, that is face mill, end mill, center drill, thread mill, and also lastly is drill. So this is a sequence that we follow step by step to cut the process. Alright, so this is what we have done on our CATIA. So this is what the step by step that we do in our tool machining. So first we start at the face mill, so we cut at the surface, and also the last step is we end at the drill, that is diameter of 7. So before we start on the machining, make sure that we assemble the part with the plane system correctly, because this is to make the machining is easy to operate the tools and to operate the material. If your assembly is wrong, so it might have some failure, or maybe the direction or the route of the process will disturb us. So this one is the machining process. So machining process that we start on the face mill. If you can see at the box number 1, that is the route of the process of the machining to cut the material. So, and then the other box is the parameter that we want to select for the process is running. After that, we do some roughing on the material. So we use the end mill diameter of 16, because this only want to cut the materials. And after that, we will decrease the tools so that we can do some finishing on our product. After that, after our machining is settled, so we will continue the process of the profile contouring. So we will cut the outside of the material. So in this box, you can see the route of the tools, and actually it repeat from the profile controlling number 1 until profile controlling number 7, because it's the same process. It uh, just cut the tools part by part or sequence by sequence. So we set that set like that, so maybe so it will have the better finishing on our product. So after we done our profile contouring, so we continue on the pocketing. So if you can see the pocketing on the number box number 1, so that is our pocketing. So also the same things that we do on the pocketing, just we repeat on the other parts. So the tools, we just set the parameter is same, just set the approaching and the retract of the tools done on the machining. So after that, after finishing the pocketing, so we do the pocketing inside, because inside the HUB sprocket they have a hole inside the diameter, hole inside the material. So this process is done to make a hole inside the material. So after we done on the machining, on our product we have 4 holes to do some the thread on our material. So before we do some drill, we need to do spot drill, because this is for we want to make the we want to make the better finishing on the hole. Because if you directly cut the workpiece, maybe have some harm on the product, also maybe can break the tools something. So that's why we need to do some on the spot drilling first. So we do the spot drilling by only set the one of the point, and just follow follow the parts of others. So the machine will will do point part by parts, or circle by circle. And lastly is after we do the spot drilling, and it will continue to the drilling deep of hole, that is we use the diameter of 7, and the root also we can follow as we set on before this, and the previous that we set on the spot drilling. So like that. So that is our machining process, and I will continue my group will continue the presentation about the final product video and also the NC coding. Thank you.
Alright, so I will continue with CAM and machining simulation. So we have block and purpose. Alright, so this one N1, N2, N3, N4 and more below, that is numbering of programming. Okay, so G54 is fixture offset and G90 is absolute program. Okay, that is stand for start program. Okay, so N3 is numbering for program number 3. Okay, so T1 is tool number 1, which is we use for the face mill, and M6 is tool chain for tool number 1. Okay, same below T2, tool number 2, M6, tool change to tool number 2. Okay, that is stand for tool change. Okay, and below is G90 and Z100 and M30. M30 is end of program for the overall program. Okay, so we will continue for the next slide.
Jangan terlalu laju pacuwe, tahan tenaga kita goyang santai. Ikuti tempo biar keringat santai, sengaja bikin pelan kasih minyak lantai. Kasih slow, kasih slow, kasih slow, kasih slow tempo. Kasih slow, kasih slow, kasih slow atau nanti kacau. Ho ho.
atura. Absen beat, ini bukan mesin jahit. Tempo irit-irit supaya kamu tidak sakit. Masa su capek? Aduh kok boring. Dari cap sampai balok, mari kita goyang santai.
Jangan terlalu laju macuwe pacuwe, tahan tenaga kita goyang santai. Ikuti tempo biar keringat santai, sengaja bikin pelan kasih minyak lantai. Kasih slow, kasih slow, kasih slow, kasih slow. Jangan terlalu laju macuwe pacuwe, tahan tenaga kita goyang santai. Ikuti tempo biar keringat santai, sengaja bikin pelan kasih minyak lantai. Kasih slow, kasih slow, kasih slow, kasih slow tempo. Kasih slow, kasih slow, kasih slow atau nanti kacau. Ho ho.
Jangan terlalu laju, goyang pelan di situ. Tahan posisi, kasih goyang kaki, jangan sembunyi siku. Buat yang sadar, kamu tangan kasih lebar. Khusus untuk yang gangguan, mohon goyang ikut aturan. Absen beat, ini bukan mesin jahit. Tempo irit-irit supaya kamu tidak sakit. Masa su capek? Aduh kok boring. Dari cap sampai balok, mari kita goyang santai.
Jangan terlalu laju macuwe pacuwe, tahan tenaga kita goyang santai. Ikuti tempo biar keringat santai, sengaja bikin pelan kasih minyak lantai. Kasih slow, kasih slow, kasih slow, kasih slow.
Alright, so I will continue with result and discussion. So here, the yellow color is finishing surface and the blue color is clamping purpose. Okay, so here the result, the final result and modeling for the overall the process. Okay, so we will continue for the next slide. Alright, so I will go through the summary, result and discussion. So here, I would like to share the problem and the difficult things during this project. So number one is, we had the problem to get the real dimension. Actually, we don't have the real parts, so we cannot measure the part, and we cannot get the exact number for the dimension, and we are decide doing the research for through the website. And sometimes some of part we are really need to consider the dimension size. Okay, for the number two is selecting cutting tools. We have two option here, which is roughing and mill and finishing and mill. So we are decided using the roughing and mill for the profile contouring and finishing and mill finishing for the finishing surface. The most challenging in selecting operation machine. So here we have a two option operation machine which is profile contouring and pocketing. Our part has a circular pocket. We are also use pocketing, and we can also use the profile contouring. So we are decided using pocketing because the setup is more easier than profile contouring. Okay, so we go through the conclusion. So based on conclusion that after doing this project, we are understanding meaning of CAM for industry. So we are now CAM is computer aided manufacturing. So using a software to translate drawing and data into detailed instruction. So here we know the CAM is a platform for the industry. Okay, and number two is we are knowing the process how to build 3D modeling. So we know the first step how to build a 3D modeling is start from sketching, build 3D modeling, and proceed to the machining process, okay, and generate the program. So there we are learn how to generate the program before running to the machine. Okay, CATIA software are really helpful to make easy way in machining. Just like we know, before machining, we are need to see and check the simulation operation so we can make sure that no error during machining. Okay, that's all from me. Thank you for watching.